Find the surface area generated when the graph of the function y equals 1 minus x squared for x is between 0 and root 3 over 2 is rotated about the y-axis. First step is to figure out which form of the surface area calculation integral you're going to use. And it all starts by recognizing the axis which you're rotated about. When it says rotated about the y-axis, the general formula for surface area is 2 pi times the integral of x ds. So it's just a matter of, do you want to do this integral in x or do you want to do this integral in y? And your decision will be then to change the inside if you're going to do it in y or not if you're going to do it in x. Let's take a look. If you're going to do it in x, then x is going to stay as an x. And then the ds part of the integral will be the part from arc length that has the formula with x in it. If you decide, though, to do the integral in terms of y, then the x can't stay there. If the integral's in y, you can't have an x there. So we replace that x with the formula g of y. And then the ds part will be the y version of the arc length formula. To get a clue as to which one you should do, it's based off of what you are given. We're given y is a function of x, and we're given an x range. So that's a clue that you should try to do the integral in terms of x. So x is going to stay as an x, and replace ds by the x version of the square root formula of the arc length formula, and we're going to go from 0 to the square root of 3 over 2. We're going to start this process, though, by working on this root. This part of ds, we're going to simplify that as much as we can before we go and come back to the integral. So we need to simplify it. How? Well, take the derivative. 1 minus x squared's derivative is minus 2x. Minus 2x. And then we square that, and we get 4x squared. We add 1, we get 1 plus 4x squared. Take the square root, and we leave it just like that. The root of 1 plus 4x squared. Don't think that you can take the root of each one of these. It doesn't work with the plus in between. So that's it. We're ready to then go and plug this into the integral. The version of the integral that we had from the first slide had an x on the outside, and this root was replaced by exactly what we calculated on the second slide, the root of 1 plus 4x squared. And so it's our job now to calculate this integral. And what you're going to notice is that the power on x inside is 1 more than power on the x outside, so that's a chance for u substitution. Let u be 1 plus 4x squared, then du will be 8x dx. 1/8 of du is going to be x dx. It's going to take the place of x dx. We have to replace x dx, and we have to also replace this root, but then that's just going to be the root of u. 2 pi stays on the outside. Don't worry about the limits here. And we replace the x dx with 1/8 of du, and then we have u to the half. Instead of being under a root, we write it to the half. Pull out the 1/8 and the 2, and that will end up as a pi over 4. This 2 could cancel this and make it a 4, and you end up with pi over 4. Find the antiderivative of u to the half, you get u to the 3 halves. Instead of dividing by 3 halves, we times by 2/3. Then we cancel. The 2 can turn the 4 into a 2. So we're talking about pi over 6 times u to the 3 halves. And this u substitution is just scratch work to help us figure out this antiderivative of the current integral that we were at. And it's exactly pi over 6 times what we had for u raised to the 3 halves, evaluated with our x numbers 0 to the square root of 3 over 2. Be a little careful here. We're going to plug in the square root of 3 over 2. We need to square it. Order of operations say we multiply by 4, add 1, and then take it to the 3 halves power. But when we plug a 0 in, we just get 1 to the 3 halves, which is just 1. So we need to square root 3 over 2. Square the top, square the bottom, you get 3/4. These 4s cancel each other out, and you have 1 plus 3, which is 4. And that's raised to the 3/2 power. Now, you know, 4 to the 3/2 is familiar 2 squared to the 3/2, so they cancel, and we get 8. 8 minus 1 is 7. Final answer to this question is that the surface area generated will be 7 pi over 6.